Hey there, I'm Jeff, and I'm back with another project for you. I'm really excited about this one. We're going to take a Raspberry Pi and a little motion sensor, and we're going to put it on this toy train as it goes around the track. We're going to use the sensor and the Raspberry Pi to gather some data about how the train is moving, and we're going to use that information to figure out what the shape of the track is. But wait, why do we need to write code to do that? We can just see the track. Well, I'm glad you asked. The next part of the challenge is to use the program that we write to gather that data to determine the shape of a track that we can't see. We're going to have somebody else set up another track in a different shape, and we're going to use our program to figure out what that shape is. I like this project for a few reasons. It's a great way to sort of get your hands into a project with a Raspberry Pi if you've never used one before, learn a little bit about it, learn about Raspberry Pis and sensors, and see if this is something that you want to learn a bit more about, maybe do some more projects with. You don't need a whole lot of math in order to solve this challenge, but if you're interested in math, or depending on how much you want to push yourself and challenge yourself in this project, you can end up using some geometry or trigonometry. You could write a more complicated program that actually draws the shape of the track instead of just giving you the information you need in order to determine it. So you can really get creative with this. Just all around, it's a great stepping stone project. So that's enough talking though. Let's get into this. Okay, so what parts are we going to need to do this? Well, you're going to need a train and a track. This is a Brio train. Maybe you played with one of these when you were a little kid. Maybe a parent, grandparent, uncle, friend, whatever, has one of these sitting in their basement not getting used, so this is a great time to dust that off. If you can't find one of these, a regular old train set will do. You really just need something that can go around the track by itself, so that you can make some observations while it's doing the work of driving itself for you. You're going to need a Raspberry Pi Zero. This is a Raspberry Pi Zero W. That's the one you want because it's got wireless built in, and that's going to make it easier for us to connect into this and tell it what to do and get the data back off of it and all of that. There's also going to be a link in the video description to an operating system image for this. So it's one that we made here at LoisLab. It just makes a lot of things easier, like having all the tools installed on it that you want to use, and it also sets up its own wireless access points. You can connect into it with a laptop really easily, and it's got a programming environment on it called Cloud9 that you can write your Python code in. So it's got all that stuff on it. If you want some more information on that and a guide on how to install it, you can find a link in the video description. Next would be the motion sensor. So this is an MPU 6050 IMU, or Integrated Motion Unit, or something, I'm not sure. I can't remember what IMU stands for, but that's all right. All that means is it's got an accelerometer and a gyro built in. So if you haven't dealt with these before, let me just explain a little bit about what a gyroscope and what an accelerometer does. So an accelerometer basically measures acceleration, like you might have guessed. So when it's sitting flat on the ground here, it's going to measure acceleration on this axis, the vertical axis, due to gravity. And then if you were to move it in this way or this way, it's going to measure that acceleration in those directions. So you can use this to measure orientation, right? When it's sitting still, you can figure out which way gravity is going, and that gives you orientation. And also acceleration in other directions when you're moving. The gyroscope is a little bit different. The gyroscope measures rotational motion, right? So if you're moving it around like this, it's going to tell you how fast you're rotating. And it'll do that on any of the three axes. There's a little label that shows you the different directions of the axes. There's a z-axis going this way, maybe the x-axis going this way, and the y-axis going this way. And so when we get data from the sensor, it's going to tell us that with respect to those axes. So if you look at the gyro data and it says you're rotating at a certain number of degrees per second around the x-axis, that's probably like this, for example. We'll talk more about that later. If your Raspberry Pi and your sensor don't have the headers already soldered in place, you might need to do that. I'll put a link to a soldering video. It's really easy to learn, but a great skill for these sorts of projects. We're going to use these jumper wires. They're called DuPont wires. They've got these little female connectors on the ends, and they just plug into these pins, making it really easy to just hook everything up without having to do a whole bunch of soldering. You can get these on Amazon or from Adafruit or any of those kind of electronics hobby supply places. You're also going to need a battery of some kind. So this one right here, whoops, I'm making a mess. Let's move some of this stuff out of the way. This is a USB battery pack. I like to use these in projects because you know, a lot of us have these kicking around, or you can find them really inexpensively. And since the Raspberry Pi can run off USB power, you can plug your USB cable right in here and then run the Pi off of that. So now this is totally portable. This is a little bulky though, especially when we're talking about sticking stuff on the train, right? It's almost as big as the train is. So in a case like that, you might want to get a smaller battery. This is getting into a little more advanced topics here, but you can get little tiny lithium-ion batteries like these. I got a 4-pack of these plus the charger for it for about 12 bucks on Amazon. And technically these aren't powerful enough, or not enough voltage for how you're supposed to run a Pi. This is only 3.7 volts, but I can tell you from experience that you can stick a couple of wires in there and wire it in directly to power the Pi, and this will run the Pi for probably 45 minutes or so, which is plenty enough time for this project. So the advantage of something like this is that it's a lot more compact. You can fit this and the Pi on here without it being so bulky. But you know, if you haven't dealt with lithium-ion batteries and hooking them up and all of that kind of stuff before, or battery chargers, I wouldn't bother with any of this. I would just stick with the USB battery pack. This is totally going to work fine. Doesn't have to be pretty. We just got to get all this stuff stuck together so it goes around the track. No big deal. So for sticking things together, we'll also use a little bit of double-sided tape and maybe a pair of scissors. And that really should be about it. So why don't we put this thing together and we'll see what that looks like. Okay, let's put this thing together. Now, as I mentioned before, using one of these USB battery packs, this might seem a little like ungainly, like a little awkward, but I think we can stick this together in a way that's going to be stable enough to go around the track without falling over. And that's really the most important thing. So let's start with a little piece of double-sided tape right up the front. Now, if you're using a different train, obviously this might look a little bit different for you, but really the whole idea is just to get this stuck together well enough that it's stable and is going to make it around the track. You could use rubber bands, you could use masking tape, whatever you have. I like double-sided tape because it's pretty versatile and it's pretty strong. But again, you know, be creative and use what you have access to. Now, the MPU 6050 sensor here, it's got some pins on the bottom, right? So I'm going to stick the tape over here so these pins are hanging off the end, and that way it'll sit nice and flat. Now the sensor is going to read best if it's sort of like square, like parallel with the plane of the ground and square with the body of the train. That way the numbers are going to make the most sense because you've got one axis going through the sensor this way, one axis going through the sensor this way, and then one going you know, vertically down. So if you square up the sensor with the train, the numbers are going to make more sense. I think that'll be a little bit more clear later. Okay, and now we need to stick the Raspberry Pi on here. So we'll use another piece of tape right here in the middle. Peel that back, and then stick the Pi on there. Now again, this is not my most elegant creation. If you're looking to stretch a little bit further in the sort of the fabrication aspects of this, and you have access to like 3D modeling software and a 3D printer, you could definitely make a bracket that would slip onto this train and hold all these parts for you. But you know, in a pinch, look, I mean, this is holding still. I mean, holding together just fine, and you know, it's not super tippy. So we'll test this out in a sec and make sure it still goes around the track. Now, the next part of this is the wiring. Now, because we're using a sensor like this one, the MPU 6050, I like this because it has an interface on it called I2C. Exactly what that means is probably a conversation for another time, but what you need to know is that it just uses 2 wires to send all the data back and forth. So there's only 2 wires to connect, and talking to it via software is super easy. So we're going to hook up the 2 data connections to 2 pins on the Pi, and we're going to hook up the 2 power connections to 2 pins on the Pi, and that's it. Super easy. So let's start with power. On the sensor, there's a pin on this end labeled VCC, that's positive power. So we'll put one of these jumper wires on there. And the other side of the jumper wire is going to go to the 3-volt connection, which is pin number 1. Now if you're looking at the Raspberry Pi and this is the SD card slot, the pin on the inside closest to that SD card slot is pin number 1. I'll put a pinout of the Raspberry Pi up on your screen for reference to help you out. Pin number 2 on the sensor, the next one over, is the ground connection. That's the negative battery connection. And so that's the next pin over on the sensor. And then over on the Pi, that's pin number 9. Now the way numbering works here is pin 1, like we said, is closest to the SD card slot. Pin 2 is on the outside right next to it. Pin 3 is back on the inside next to pin 1, then 4, then 5, then 6. So all the odd number pins are right down here. We want pin number 9 for the ground. Oops, my pin came off the sensor. I'll fix that in a second. But pin number 9, we can just count along the odd numbered pins. 1, 3, 5, 7, 9. Plug this back on the negative power connection there. The next pin on the sensor here is labeled SCL. That's one of the data connections. So I'll put this wire red on SCL. And the SCL pin is pin number 5 on the Raspberry Pi. So that's pin 1, 3, 5. I might have to tighten up these wires a little bit because one of them keeps sliding off. Slip it back on for now. We'll fix that in a second. And then the last pin, which is labeled SDA on the sensor, that goes over to pin number 3, which is right here. And that's it. You get the 4 pins on the sensor over here connected to the 4 pins over on the Raspberry Pi. So that's VCC on the sensor goes to pin 1 on the Pi, ground on the sensor goes to pin 9 on the Pi, SDA on the sensor goes to pin 3 on the Pi, and SCL on the sensor goes to pin 5 on the Pi. And that's it. Now the reason that I put the battery pack and the sensor where they are is so I could still get access to the switch. If you're using a different style of train, that could be a little bit different. Just sort of adapt it, you know, as you need to. Make sure everything fits. Make sure you can turn it on and off, and you're good to go. So move the camera out of the way, and we'll make sure this goes around the track okay. Okay, for this next part, we need to power up the Pi. So I'm using the USB power connector that came with the battery pack, and I've plugged it into the power connector on the Raspberry Pi, and I know it's working because the lights on the USB battery pack lit up, and the green light on the Pi lit up, and so it's booting up. Now, if you're using the LoisLab operating system image, after about 30 seconds or so, this will be done booting, and you'll see, if you look at the available wireless networks on your laptop, you should see one show up that's called something like LoisLab Pi dash and then a number. In my case, it's LoisLab Pi dash 05. I'm going to connect to that access point, and then I'll be able to point my browser at this Raspberry Pi's access point and get my Cloud9 development environment. So I'll pull that up on the screen now. Okay, so I've got my browser up, I'm connected to the wireless access point on the Pi, and I'm in Cloud9. So the next thing I want to do is to pull down the example code that's going to show us how to read data from the sensor on the Pi. So to get that, I'm going to go to the GitHub site, the LoisLab GitHub site. There's a link in the video description. And I'm going to go to the GitHub repo called PyTrain. That's where the example code is. So if you go into that repo, there's a green button on the right-hand side that says clone or download. And you can copy that URL. And when you go back to Cloud9 and you go into the command line tab here where you can type commands, we can use the git clone command to pull a copy of that repo down so we have a local copy of the test code. So we'll do git clone and then paste in that URL that we copied from the GitHub site, and it's going to go out and grab that code. And so now if I go into the PyTrain directory, or I can use the little file browse thing up here on the left, I can open up that PyTrain example code. So let's walk through this together really quickly. If you haven't seen Python code before, this might look a little confusing, but it's pretty readable, and if you're a little bit patient, I think this will start to make sense to you pretty quickly. Let's walk down through it. These first couple of lines import some libraries that we're going to need. This first one is the MPU 6050 library. That's some code that somebody else wrote that lets us talk to the sensor and get data from it. Next, we're importing the sleep command from the time library, and the sleep command is just like a wait. When we're writing Python code and we want to have it wait for half a second or wait for 10 seconds before doing something else, we use that command. This next line creates an instance of the MPU 6050 sensor, and that number on the end just tells the Pi what address on the I2C interface to look for that sensor on. Again, don't worry too much about the details there. And then we've got some comments here that tell us a little bit about how what accelerometers and gyros do. And then we get into this loop code. While true, just loops infinitely. Read some accelerometer data and stick it in a variable called accelerometer data. And then read some gyro data and stick that in a variable called gyro data. And then when we read data from the sensor, the library puts it in something called a dictionary, which is just a certain type of data structure, kind of like a list. And I'm breaking it apart so it's a little easier to work with. So I take the X, Y, and Z orientation data out of the dictionary and put it in their own variables called X orient, Y orient, and Z orient. And then I do the same thing with the rotational data from the gyroscope. Put that in its own variables. And then I print it out, and then I wait for a second. And that loop is going to run over and over and over again. So to kind of summarize that, it sets everything up, and then it goes and reads data, breaks the values apart, and prints them out. And then it waits a second, and then it does it over again, and it keeps doing that until we tell it to stop. So if we've got the code ready to go, and we've got the train all set up, we can turn it on and send it around the track. We can take a look at the data that we're getting back from the sensor and see what we can figure out about what the train is doing and how it's moving around the track. So we're getting orientation data from the accelerometer that tells us a little bit about the position that it's in. And also some data from the sensor as it accelerates in a given direction. We've also got some data coming back from the gyroscope that tells us about how it's rotating and how fast. So I would like you guys to take a look at the data and see if you can figure out which numbers that are coming back can tell you when the train is doing things like turning or going straight. And that is the information that you're going to be able to use in order to map the track when you can't see it anymore. So just for now, I want you to try hacking on this code and modifying it to give you the information that you want and present it in some way that's helpful to you. I'm going to stop there. If you would like some hints on where to go next, I'll give you a couple. But if you're ready to jump into this project, I really think you should take your first crack at it yourself without any hints from me. See how far you can get, and then if you need a little bit of a nudge, go and watch the hints after the pause that's coming up. Or send me an email or contact LoisLab through the information that's in the video description if you want to ask us some questions. All right, I'm going to pause here. Don't go any further unless you want a hint. Okay. Okay, are you puzzling over where to start? Do you need a little bit of a hint? Okay, we'll give you some. Take a look at the numbers that you're getting back from the example code. Some of those are giving you some information about the position that the train is in at any given point in time, or how quickly it's accelerating in a given direction. Some of those numbers have to do with if the train is turning, rotating in a certain direction, and if it is, how fast. Think about what those numbers are and what they tell you. Or as the train is getting to a point in the track, like where it's going straight or when it's going around a corner, look at those numbers and see which ones change. And look at how they change. Do they go positive or negative? Do they get higher or lower? Those numbers should be able to tell you something about what the train is doing at different parts of the track. If you just want to look at the data and interpret the data as it goes by, maybe that works for you. But if you want something that works a little more intuitively, maybe you want to write some code that checks those numbers as it goes through the loop. And as it gets to certain values, or it gets, if the numbers go in a certain direction or get positive or negative, maybe the program can tell you, hey, I'm turning left, or hey, I'm turning right, or now I'm going straight, or something like that. Your program could draw a picture of the new track. These are all totally possible. Don't be afraid to experiment. It's a normal part of a process of working through a challenge like this and writing code like this, that you're going to try some things and it's not going to work. And you're going to have to try some other things. That's totally normal. That's totally fine. Don't get frustrated. It's just part of the puzzle. If you really get stuck, there's some contact information in the video description. You can reach out to us and we'll give you another hint. Okay, so if your program is working and you've got it telling you what the train is doing as it goes through the different parts of the track, then you're ready for the next part of the challenge, which is to have somebody build you a new shape out of the track pieces. And you can use your program to figure out what the shape of that track is without looking at the track itself, right? Sit in the next room and use your program and the information that the Raspberry Pi gives back to you and figure out what the shape of that track is. So you should have everything you need, so go and get started. If you have any problems, you have any questions, reach out to us through all the usual means and tell us how it's going. We'll talk to you soon.